Morning everyone. So welcome back all of you in class 9th science, and we are studying chapter 9 force and laws of motion. And students, we have studied in our previous session the Newton's first law of motion. So and we have discussed about the inertia also. So what is inertia? Inertia is the natural tendency of an object to resist a change in its state of motion or of rest, and the mass of an object is measure of its inertia. So students, we can say that inertia of an object is measured by its mass, and you know that inertia is directly proportional to the mass. So we can say that mass and inertia, what is the relation between mass and inertia? We can say that inertia is directly proportional to the mass. It means that inertia increases with increase in mass and decrease with decrease in mass. So we can say that heavy object has large inertia and the light object has less inertia. So now we know that a heavy object will have more inertia, and then light object is having less inertia. So inertia of an object is measured by its mass. Now we will study in detail about the inertia and mass. A body at rest continues to be at rest, and a body in motion continues to be in motion. This property of body is called its inertia, and the inertia of body is measured by the magnitude of force required to change the state of the body. The force required to change the state of a heavier body is more than the force required to change the state of lighter body. This is because the mass of the heavier body is more than the mass of the lighter body. So the mass of the body is measured of its inertia. So now we know that a heavy object will have more inertia than the lighter one. Now we'll discuss about the another physical quantity, that is momentum. What is momentum? The product of mass and the velocity of moving object is known as a momentum, and it's represented by P. So we can say that momentum measures the quantity of motion possessed by a body, and it is defined as the product of mass and velocity of the body. Beside the magnitude, momentum also has a direction. So at any instant, its direction is the same as the direction of the velocity. So if a body of mass m moves with the velocity v, then momentum p is given by p is equal to mv, and the SI unit of momentum is kilogram meter per second. So what is momentum of the body? The momentum of a body is the product of its mass and velocity. So momentum is denoted by the p. So we can say that momentum is equal to mass into velocity. P is equal to mv, where p is the momentum of a body, m is the mass of the body, and v is the velocity of the body. If a body is at rest, its velocity is 0, so its momentum is also 0, and the SI unit of momentum is kilogram meter per second, or we can write down as a kg m per second. For example, a truck moving at very low speed can kill a person standing in its path because of the heavy mass of the truck. A bullet of small mass, when fired from a gun, can kill a person because of the large velocity of the bullet. So the impact of the body depends upon its mass and velocity, and the product of mass and velocity is known as momentum. So we can say that if a body is at rest, its velocity will be 0, so the momentum will also be 0. Now we'll discuss about the Newton's second law of motion. So what is the second law of motion, or we can say second law of momentum also? So the rate of the change of linear momentum is equal to the force applied and the direction of the force is always in the direction of the change in momentum. So we can say that F is equal to ma. Now we will study this second law in detail. What is the second law, or we can say the second law of motion, or we can say the second law of momentum also. So Newton's second law of motion states that the rate of change of momentum of an object is proportional to the applied force in the direction of force. The second law of motion states that the rate of change of momentum of an object is directly proportional to the applied external force and takes place in the direction in which external force acts. Now we will see the mathematical formulation of second law of motion. If a body, or we can say if an object of mass m is moving along a straight line with initial velocity u and is accelerated to velocity v in time t by applying a force F, then initial momentum, that is P1 means initial momentum, is equal to mu, u is the initial velocity, then final momentum P2 is equal to mv, because v is the final velocity. So the change in momentum is equal to P2 minus P1, and we know that P2 is equal to mv and P1 is equal to mu. So we will substitute the formula, that is mv minus mu. Now we can take m as a common. So the rate of change of momentum is mv minus u upon t. So we can say, according to second law, that the applied force is directly proportional to the rate of the change of momentum. So we can write down F is directly proportional to the mv minus u upon t, and we know that v minus u upon t is equal to a. So we can write down a instead of v minus u upon t, and we have to write down the sign of equal to. So we are using here constant k. K is a constant of proportionality. So we can write down F is equal to kma, and the value of k is 1 here. So the quantity k is, we know that a constant of proportionality, and so 1 unit of the force is defined. So value of k is equal to 1. So we can write down F is equal to ma, and we can say that 1 unit of force is defined as the amount of that produces an acceleration. The amount that produces an acceleration of 1 meter per square. Acceleration is acceleration of 1 meter per second square on an object of 1 kg mass, that is 1 unit of force, is equal to k. So k is equal to 1, because k multiplied by 1 kg multiplied by 1 meter per second square, then the value of k is equal to 1. So we can write down, or we can say that force can be written as F is equal to ma. The SI unit of mass is kilogram, and the acceleration is meter per second square. So we can write down the unit, and the unit of force is here kilogram meter per second square, or Newton, and the symbol of Newton is capital N. And students, here I want to tell you, when the applied force F is 0, then the acceleration A is also 0, and the body remains in the state of rest or of a uniform motion. So what is the statement of the second law of motion? We can say that the rate of change of momentum of an object is proportional to the applied force in the direction of force. So that is all about the second law of motion. So thank you everyone.